Alright, so in this short video, we're proving triangle similar using the side-side-side similarity theorem. This information was pulled from a larger video which covers all three theorems, side-side-side, side-angle-side, and angle-angle. So some of the examples the example numbers may be a little off. If you notice that, that is because it was pulled from a larger video, but this video only discusses the side-side-side similarity theorem. Alright, so let's get started. The side-side-side similarity theorem states that if the corresponding sides of two triangles are proportional, then the triangles are similar. So as an example, let's say each side here, this was 2 over 4, this was 3 over 6, and this was, let's say, 6 over 12. All of these sides reduce to 1/2, and so they're all similar, and that will make these two triangles proportional. Let's look at these two examples here. So the first one here, example 6, we have a smaller triangle within a larger triangle. So the first thing you want to do is figure out the length of the sides of the larger triangle here. So the length of WY would be 15 plus 6. So the length of this side would be 21. And so WU, the larger triangle, we add 20 plus 8. So the length of this entire side is 28. And so now we want to set up fractions or proportions to see if they reduce to the same thing, to see if this triangle is similar. All right. So I'm going to start out with this side right here, WY, or WX over WY. So the smaller triangle, I'm putting it in the numerator, 15. The larger side, or that larger triangle side, is 21. And I'm going to reduce this fraction. They're both divisible by 3. So that reduces to 5/7. All right, looking at this side here, 30 over 42, 30 divided by 42. These are both divisible by 6, so that reduces to 5/7. And next, the last side here, we have WV over WU. So that would be 20 over 28. Reduce that. They're both divisible by 4. So we're just reducing the fractions here. And they all reduce to the same thing, 5/7. And so these sides are proportional. So yes, we could say that this triangle or these triangles are similar using the side-side-side similarity. Next, let's look at this one here. We have our larger triangle and smaller triangle. So let's set up some corresponding fractions, or a fraction using the corresponding sides here. All right, and so we have our smallest side, so that would be 5/4. That does not reduce to anything. Our middle side would be the 12 and the 7. So that would be 12/7. That cannot be reduced. And I can actually stop here and say that these triangles are not similar, but I'm going to keep going. So the larger sides here are 16 and 10. And we can actually reduce that to, let's say, 8/5. But it does not matter because none of these reduce to the same thing, right? And so we could say that these two triangles are not similar, or we could use this symbol here for similar. All right, so I have another problem for you to try here. Example 8, it asks, are the triangles similar? If so, write a similarity statement for the triangles. And remember, with the similarity statements, the corresponding sides have to be in the same position. And if you need some help with similarity statements, please refer back to the video I have on similar polygons. So go ahead and pause the video and go ahead and try this one on your own. All right, so these two triangles are in fact similar. Each ratio or scale factor reduces to 2/3, and so they are similar using side. And this is our similarity statement down here. You could have it set up differently. You could have triangle UTS is similar to WVX as long as those corresponding sides are in the same position. Alright, so we've reached the end of this lesson. I want to thank you for learning with me. Some related videos are similar polygons, angle-angle, and side-angle-side similarity, as well as the triangle proportionality theorem, known as the side splitter theorem as well. If you haven't already, please like, comment, share, and subscribe. And once again, I want to thank you for learning with me.